That's fine. All right. First of all, I should warn you that this talk is mainly JavaScript.
Now he's saying.
Yeah, I realize and Roto and etc. But it's important for it interacts both with Testmore, the tool suite, the Perl toolchain, build toolchain, and Dancer at the end. But I don't show much of that on screen, unfortunately. So you have your link for hardcore Perl content. Now it's time to move on.
Okay, I'm dressed.
Fair enough. All right. I guess at the last GAPS EU, what we're going to cover mainly is going to be D3.js, a way to visualize any sort of data, really. I did some research and found out that this is a library done by Washington Post people. So if you don't have much reason to go to the Post here, but in the U.S., it's one of the most established newspapers, and they do a lot of really good work on data visualization and rendering of graphs. And what I'm talking about here is going to be mainly HTML5, so reasonably modern, supported in most browsers these days. I've run this in Chrome and Firefox, and the usual candidates for lawsuits such as IE, and it seems to work on all platforms. How it operates is basically, all right, I'll talk over that. We're going to start out with output from cover in JSON format, and after a few tweaks. Cover is a tool from, let's see here, Devel cover, the tool cover suite. Sorry, code cover suite for testing code. Make sure that your test suite follows all of the possible branches through your code, and it works. And make sure that your code is covered as well as it can be. So using Testsuites and the coverage tools, everything they're seeing that you're going to be seeing here is driven via JSON. So we tell Perl to generate a JSON flag for the test suite, which partially, after running your make test on your Perl module, we get out the format in JSON format, and pass that almost directly into the suite, into this, to give us a nice visual representation of how much code is left to test, how many tests have passed. That's what we're seeing here. The border here is the HTML5 canvas. In the background, you see the Perl Dancer logo, very lightly shaded. This is a straight rendering again out of D3.js for the bubble graph. D3 has a huge variety of styles. I'll show a few more at the end talk and talk about those very briefly. But this is how I chose to represent test suite coverage. The outer ring here represents the overall code coverage for a given main model. And if this were actual HTML5, you'll be able to roll over and view more details of coverage on the model. So you can mouse over that and see 100% coverage, or in this case, 33% coverage. The inside ring, the larger green area, which is more important, is how many tests passed in your test suite. So in Between transitions that we're using, all tests here passed. Over here, one module has 33% failing tests, and down here, one module with 10% failing. So that's roughly how it's structured. Again, this is a simple tree-based JSON data representation with files at the top level sitting outside the bubble, and files in directories sitting inside bubbles. Since there's no real way, there's no, there is some training data that you pull from this if you do test cycles a year, you do test cycles every few weeks. So while there is training data, it's not easily represented in terms of, there's not an easy way to look at a cluster of 50 files represented over time and follow test screens. This is more meant for just a quick view for management to be able to see overall test progress this week or this month, to make sure that everything here that should be green is green, everything that is known to be a problem, such as the mass module, is at least shrinking in terms of data size, problem set. And zooming in a little bit more here, you see the borders around the, or between the rings and the wedges. Again, it's all driven here by JSON. So if you have so whatever test suite you have, as long as it can output JSON, you can use this tool. The important things to note here are going to be the coverage percent, which again is operating on the test file, and the passing percentage, which is the inside ring. That is what we're going to pass directly into D3. Where should we start? Where should we start by telling D3 to append to our HTML? It's a little bit awkward, but this is how you end up doing these things. Because of a fault in, I believe, IE 9 and possibly Opera. A lot of these things a lot of the weird ways they have to do things in JavaScript come from, obviously, IE implementations. And on occasion, those are, or other awkward entries. For those of you that haven't seen JavaScript before, it's actually not that far from Perl if you ignore the fact that there are no signals, and instead just treat it as you're using Chip's dots method, the dots file that he wrote last year. So you have dot instead of arrow to separate your values. And since JavaScript apparently really has no true concept of objects, everything is done via closures, which is a little bit awkward as well, because the way data is copied around. That's what this does basically is creates an SVG object for a given width and height, the X and Y dimensions on the canvas, and which ordinarily starts at the top left corner, and we translate down a little bit to make it a little bit more visually appealing. Going into the actual JSON data, we see we have a file somewhere called cover.json, which is processed and passed back to our callback, which is the function up here. So again, everything done via callback. The JSON, yes, blocked by D3, handled it all internally. And for every node in that, a node being the Perl equivalent of a hash reference, we call this function, which creates a new node from that and attaches this to our tree of SVG objects that we're building up inside our canvas. Inside that canvas, once we have a node, we plan this way. We again create a SVG data point, which is either a node, which is the actual transform cell, or on the way around, the leaf node being the actual transform cell, or the node being a bubble of cells. So very, very abstract, I realize. And if you have questions, by all means, feel free to jump in. I'm sorry, Steve Glaze looks. And yeah, sorry. So essentially, you can think of it more as a map reduce over your data set. Your data set here being all of the nodes in the file. So we're creating a new node with a class as either the leaf or the bubble surrounding that. As a callback. So everything inside here has to be scoped appropriately. If you move this function outside, you'll get an error because of the way the parameter D is tied to the actual data set. I don't quite understand that myself, but it's apparently a requirement of how JavaScript works so forth. Apparently, the D element is scoped tightly to this function created inside D3 inside the D3 JSON that we are implementing over there. So I don't quite understand that part, but am I wrong? No. Okay. Yeah, I just despite my apparent misgivings, this really is a neat library, and I've done a lot of work with it recently. As long as you can wrap your head around how JavaScript works compared to, say, Perl, it's probably fine. It's just got what we see as quirks because of scoping recommendations, and I'll speed things up drastically because we're closing on time. One thing that you can see here that should help is the translation applied to each individual node. So as we walk down the list of nodes, we displace them, given, and this is where D3 helps us as well, because D3 supplies the X and Y coordinates to move the bubbles around. So you don't have to do any of that work. D3 knows where to position the bubbles and knows where to position the individual cells. So all you're doing here is letting D3 do the work of processing the JSON file and telling you where to put things. So it's sort of an inside-out way of looking at things. For those of you that remember inside-out objects, that's kind of the same spirit. And in that spirit of, I mentioned before, of MapReduce, let's see, what are we looking at here? This is, the bubble layout is strictly a abstract design. You can use squares, you can use stars, you can overlay anything you want there inside that. All the bubble layout method that we talked about beforehand does is provides you X and Y coordinates and the overall size of the bubble. So when we have a bubble with certain radius, return, we create a circle with that radius and return that as part of a filter application. essentially MapReduce. If you're familiar with the map function, consider this essentially a how should I put this? Consider essentially a block of code passed to map. Sorry, CPU knowledge. That's good. Yes. Just bring it up a little bit better. And again, the function, the D function is, or rather, the anonymous function is what drives the entire thing. You can do anything that you want to with the radius. You can use that for name, you can display, get any color radius, but that is what the bubble layout returns to you. All it returns to you is essentially the X and Y coordinates and the radius of the bubble. So you're free to do whatever you want to with that. All right. The next part here is going to be the green circle, the green or red circle arc on the outside of the SVG layout. And we do that with, let's see here, we're not quite generating that yet, but what we're doing here is we're telling the D3 application internally to walk where we have no children, i.e. the smaller bubbles, create an arc, which is going to be the, in this case, the green arc, which starts here and rotates through 100 through pi, oh, what's it? Josh uses radians, so pi 180 over pi radians times 100%. Some fun math is involved there. But we're attaching the arc here to our overall D3 that we're building up inside the JavaScript cache. We're building up a set of objects here, and as part, you can run as many filter operations over that set as you want to. So you can just have dump out coordinates or dump out text, or in our case, dump out a set of arcs. So, I mentioned math earlier. This is as intense as it gets. I also use a slide to point out again the small quirk in JavaScript. The quirk I found to be a quirk in JavaScript, in that you can define functions as you would ordinarily, but for anything that actually involves D3, these functions need to be inside the scope that we declared way back here in terms of the cover, in terms of this. Those functions have to be defined within that so they can get the reference to D. So the
I really don't get that.
Was it?
Like you said it earlier, and I looked at it, and I didn't get it,
don't.
and I get it less every time you say it. Because
Okay.
it's an argument to the function.
Well, yeah.
And
Well,
the functions in the global namespace, like everything in JavaScript. So I'd like to see more of that later.
yeah, it should, and
Functions declare their own namespaces,
yeah,
so if you've
and
got
I
something
will-
inside the function, it's in the namespace.
yeah.
But it isn't. It's
The
not.
parameter is declared as if it was inside the function namespace.
Yeah.
But it's passed in. It's not closing anything. It's passed in.
It should be. I am in 100% agreement with you on that. And this is why I say that it's either quirk or something I knew wrong. But this is how the D3 library that I've worked with so far operates. And in point of fact, I don't understand why, and I wish I did, but if you move these functions outside of the D3.json scope, they will not work correctly. They should. I agree 100% that they're just lambdas with one argument. They should work out. They should work. I think I kind of understand why, because of the way that JavaScript passes around, the way JavaScript passes around is object references. Namely, this, and I'm running out of time here, so excuse me for a second. Namely, this block here, which I declare an outer and inner radius, as also as this time a function value. When I was trying to refactor the code to do this in a more sane fashion, I couldn't actually use the standard function inside here, the same function D that you see in there, because of the way that does things. So I'm trying. Is confusing me. Is probably confusing everyone else here, and I apologize for that. I don't have a good explanation for why. If I were better at JS, I'll be able to tell you that it's an aliasing issue in the main object, but I can't tell you that. So, but again, as long as you keep functions within the d3.json block, everything seems to work fine. But I will wind up here briefly and show you what else. This is just a sampling of what the D3 JSON library lets you do. This is the original solar system map. If you read XKCD, the Exoplanets comic from several months ago, use that library. Gas diffusion, obviously regular charts, bar, pie charts, scatter plots. It also has animation as well, so I'm not quite sure what those are, but I'll move on. This is where I got the notion for the overall circle mapping. It also does timelines and content animation and even 3D animation of. I don't see that on here, unfortunately, but it also does 3D animation inside your HTML5 window. And this one right here, you hover over that, the text expands dynamically, and it's all controlled by D3. So all you have to supply the D3 library is a simple JSON file, and let it do whatever it wants to, which is a huge, huge variety of stuff. And the glitches that I see with it probably are my inspiration for JavaScript. And I hear someone else beeping, so that means it's time for me to let you guys go on to break and have fun. This is where the code is right now. I think I will make sure that it is if it's not there already. But that's where the D3 library, my implementation of D3 either is or will be soon. I'll have to make sure that's there. And other than that, thank you.